Hello students, welcome to the session on database management system. These are the two prescribed textbook, that is Fundamentals of Database System by Elmar Srinavate and Database System Management System by Raghuram Krishnan Gairke. So the module 1 consists of 3 chapters: Introduction to Database and Overview of Database Language and Architectures, and conceptual data modeling using entities and relationships. Let's begin with data. The data is nothing but known facts that can be recorded and have an implicit meaning. When I say a student USN number, student name, it's a data. What is a database? Database is nothing but it's the collection of data with implicit meaning. It's called as a database. Database has become a backbone of many applications. For example, if I consider the day-to-day applications like email, the Flipkart, Amazon, and all the social networking sites, all depend upon the database. It might be in a small scale or large scale, but almost every application requires database. Now, the database will be stored in a storage medium, but it requires a software to create and control or maintain this database. That software is called as DBMS. The DBMS is a software that allows user to create and maintain the database. We'll learn about DBMS. The DBMS is a general purpose software system that facilitates the process of defining, constructing, manipulating, and sharing the databases among various user and application. Let us see one by one what is defining a database. Defining a database in the sense, now suppose if I want to store any student name in a database, I need to define the data type. I need to specify the structures, the length of a particular the name, and also that has to be stored into the database. Constructing the process of storing the data on a storage medium that has to be controlled by the DBMS. And then comes the manipulating. Suppose the DBMS allows to fetch the data from the database, insert the data into the database, and also to update or modify the data in the database. And then it facilitates sharing, that is concurrently accessing the database by multiple users. Well, this diagram shows a simplified database system environment. At the outset, we have users. The users can be end users, can be a database administrator or a programmer. All this communication to the database is done through a queries. So the DBMS will process the queries, and again it is interrelated to connected to the database. Suppose if you want to fetch the data will be sent to the user, or if you want to modify the data will in the database will be modified. At the left side of the store database, we have metadata. Again, this is one of the key, one of the main aspect of one of the database, where this metadata is nothing but the description of a data. So the description of a data is nothing but called as metadata. So it consists of the number of relations available in the database. It consists of the attributes and their types and the number of columns available. All the information of database is available in the metadata. So this shows the sample. This is a sample logical representation of a university database where we have 5 tables or 5 relations, and can you see the student relation has 3 columns, or is a name, student number, and class. So that is called as attributes, and the rows are called as tuples. Yeah. This shows the difference between, this diagram shows the diagrammatic representation of file system approach and a DBMS approach. Here, according to the file system approach in the late 1970s, if I am a user, if I want to store any data in the database, I will be storing it in a file. And if I want to fetch the data, I will collect it from the file. I will get it from the file. Again, every user, they used to maintain a separate file. So because of this, there were a lot of disadvantages. There were no multi-user access. There were no multiple views of data, and there was lots of redundancy because of which there was a lot of redundancy. And nowadays, after that, architecture was developed that is called as client-server architecture, where the data is there was a centralized data, and all the users used to share the data by the help of a software that is called database management system, with much more features compared to additional features compared to file system approach. Yeah, this is one of the very important topic, that is characteristics of database approach. The main characteristics of database are self-describing nature of the database system, insulation between program and data abstraction, support of multiple views of data, sharing of data, and multi-user transaction processing. Let us look to one by one. Self-describing nature of a database system. As I said, as I shown in a previous slide, each database will have a metadata that give a complete description of a database. The metadata will have the structure of a database, data types, number of columns available, number of attributes available, number of tables available. All the descriptions of databases are available in a metadata. That's why we say a database, we say it as a self-describing nature of a database. Look at this. This is called as a metadata, where it describes a database completely. In the first block, you can see the relations. It shows the number of relations available and the number of columns. And in the second block, it says, in the second table, it says column name. It shows column name, data type, and then the belongs to which relations. All the information are available in the metadata. A DBMS catalog stores the description of a particular database, example, data structures, types, and constraints. So this description is called as a metadata. The second characteristics of database is insulation between programs and data abstraction. In the old traditional file processing, the structure of the file is embedded in the application program. Any changes need to be done to the application program. We need to change the application program. Or if any changes we need to do it for the file, we need to change the entire application program need to be modified. But in case of DBMS, suppose if you want to add one information to a particular database, just we need to, for example, if I want to add date of birth to a student database, I can easily add it to a metadata, and that will get reflected in the database as well. So this feature of a database is called as program data independence. The next is support of multiple views of data. The database has many users, each of whom may require a different perspective view of the database. For example, if I consider an academic management system where student and the teachers will be using the same database, but the privileges or the authorization or the view given to the teachers and students will be differed. The students can access only the attendance and the marks, whereas faculties or the teachers have the privileges of having much more information. They can see the students' parent details. The faculty can add the attendance. They can add the marks as well. Much more privileges compared to student. If I take an other example of a bank, the bank and the customer will be using the same database, but the view is entirely different to the customer, and when it comes to manager, it is entirely different. Much more privileges are given to manager, where the manager can add the customer details or modify, like much more privileges is given to the manager view. So that is one of the major characteristics of database, which is not available in traditional file processing technique. Sharing of data and multi-user transaction processing. As the name itself says, multiple user can access the database. DBMS must include concurrency control software. When I say concurrency control, for example, a bus reservation system, in a bus reservation system, n number of users will be trying to book a particular seat, but the DBMS will allow only one user to book a seat. So this approach or this technique is called as concurrency control. So this type of application are called as online transaction processing application. DBMS should enforce several transaction properties like isolation property, where each transaction should be isolated from other transaction, and atomicity property, where ensures that either all the database operation in the transactions are executed or none. For example, if I perform a fund transfer operation where the amount has to be debited from my account and it has to be credited to my friend's account, in the meanwhile, after debiting, in the meanwhile, if there is any power failure or a system crash, there should not be any scenario like it has been debited from my account and it has not been credited. No, no, there will be no such scenario because of according to the atomicity feature, either the transaction should occur or none. So that is one of the key feature of database approach. So these are the two types of users, that is actors on the scene and the workers behind the scene. Those who actually use and control the database, or those who design or develop and maintain the database applications are called actors on the scene. The one who design and develop the DBMS software are called as workers behind the scene. Again, database administrators is responsible for authorizing access to the database, coordinating, monitoring its use, and acquiring software and hardware as needed. It's the responsibility of database administrator to provide a multiple view to the various users. And if at all, if it's the responsibility of the database administrator as well for if at all if there is any breach of security and poor system response time. The next is database designer. The responsibility of the database designer is to define the content, the structure, the constraints of the database. So whenever they prepare the structure of a database, they need to communicate with the end user and understand the needs and then design the database. So this is end users. These are the actors on the scene. We have casual users, parametric end users, and sophisticated end users, and standalone users. Casual users, so these will be using the databases occasionally, like middle or high level managers. So each time when they use the database, they expect a different information. Parametric end users, these example of parametric end users or naive users are bank tellers or the the reservation staff. The key feature, they used to communicate, they will be communicating with the database using a graphical user interface. So they will not be directly communicating with the database. With the help of a graphical user interface, they will be communicating with the database. And then comes the sophisticated users. So these include business analysts, scientists, engineers. So these people will be directly communicating with the database using a complex queries. And then the standalone users. So usually the person maintains his own database and querying it. So this is an example. Example is a tax program user creates his own internal database. So that such users are called as standalone users. So these are the workers behind the scene. The one who uses DBMS software, like one who designs a DBMS software, and the two developers, operators, and maintenance personnel. All these are the workers behind the scene. The advantages of using the DBMS approach. So we have controlling redundancy, restricting unauthorized access, providing persistent storage for program objects, providing storage structures for efficient query processing, providing backup and recovery, providing multiple user interfaces, representing complex relationships among data, enforcing integrity constraints, permitting inferencing and actions using rules. So let me divide this entire advantages, so 9 advantages, based on storage. Based on the storage, I will be dividing it as controlling redundancy, persistent storage for program objects, and based on security, I will divide it as backup and recovery, restricting unauthorized access, enforcing integrity constraints, and based on efficiency, I will separate it as the storage structures and search techniques, multiple user interface, complex relationship among data, inferencing and action using rules. First, let us look into controlling redundancy. Redundancy is nothing but a waste or duplicate data. In the traditional file processing approach, there was no concept of multi-user processing. There was no concept of multi-user, or there is no concept of sharing. Each user used to maintain the separate file, data in a separate file. So because of this, there was a lot of redundancy. Hence, in a database approach, the redundancy is being controlled and reduced. Now, why redundancy has to be controlled? Because there will be a wastage of storage space, duplication of effort, and there will be inconsistency of data if there is any redundancy. So this is one of the first advantages, that is controlling redundancy. Providing persistent storage for programs. In a traditional file system approach, once all the objects have been initialized, when the program is terminated, the memory will be discarded, the entire object will be discarded. So I can take an example. So the DBMS will store the entire data in a particular file. Again, in a traditional file processing, we can store it in a file, but it is a bit tedious job. So this is a persistent storage for program, where it is tedious when it compares to a traditional file processing approach. The next one is restricting unauthorized access. In DBMS, we have advantage of restricting unauthorized access, such that we can give a subset of database to a particular user. The user, as I said, an example, the view of a customer will be entirely different for the view given to the manager of a particular bank. In a DBMS, a person is given access to only that information that she has permission to access. This is achieved by creating different database user accounts with different privileges. Providing backup and recovery. The backup and recovery subsystem is responsible for the recovery of the database in case of software or hardware failure. For example, you might have come across a situation where you go to where you go to ATM, and when you try to withdraw an amount, the system fails, and you will get a message telling that amount has been debited, but the system doesn't deliver the currency notes. So after this message, after 5 or 10 seconds, you'll get one more message telling that ATM reverse with minus debited amount. So this is one of the feature of recovery. Even though the hardware has been failed, even though the amount has been debited, again it has been reversed. Reverse debit happens soon. So this is an example of recovery. This is the fifth advantages, enforcing integrity constraints. The DBMS have the capability to define and enforce the constraints for the data. For example, in the name column can have maximum of 50 characters, or age value of a student shouldn't be less than 6 years. So these are the constraints on a particular attribute, or the course ID for each student ID shouldn't be empty. So this is something called as referential integrity, and the USN number should be unique. Again, this is a uniqueness constraint. So these are what we enforce integrity constraint. If I take one more example as other number of an employee, that should be unique. So this way, if we make any other number attribute as a primary key, so that value will be always unique. Sixth advantage is providing storage structures and search techniques. Again, this is one of the key features of database approach, where you can use a faster query processing and optimization technique with the index, which are tree data structures, and efficient queries for faster execution according to the indexes. So this is one of the key feature where we can access the databases, access the data very quickly and efficiently, providing multiple user interfaces. A DBMS is designed to handle multiple users at the same time. At the same time, the user interfaces for the faculty will be different when it compared to the student. As also, it will be different to manager when it compared to the clerk, and also different compared to the customers. And the next one is representing complex relationships among data. A DBMS must have the capability to represent a variety of complex relationship among the data. Due to this, we can access any amount of, because of this complex relationship, we can fetch any data. For example, if there are two tables, two relations, for example, employer relation and a project, if I want to know which project Smith is working, I can easily access. This is just because of the relation between the two tables. The next is permitting inferencing and actions using rules. Yeah, in DBMS has database approach has a trigger where we can set whenever an event is occurred, when an action has to be performed. Also, we can set some rules, assertion rules, like the employee age should be between 18 and 60. Any if you try to insert any age which is less than 18 or greater than 60, it will throw an error. So so this is about the permitting inference and action using rules. Some databases have the capability to set some rules and to continuously check that rules are complied, and if the rules are complied, then to a specified action, and if the rules are not complied, then to do another specified actions. So this could be done with the help of triggers. We have also features called as assertion. Yeah, by this we have done with the nine features, nine advantages of database. uh, I want students to make use of a mnemonics to learn all these nine advantages. uh, yeah, thank you.